Alright, hi everybody. Just want to give you a short little clip today on biomes. And if we're looking at why we have all this diversity of life on Earth, and our planet is very unique in that. And how does some of the non-living conditions, some of those abiotic things that we talked about, impact the living conditions? So if you want more information on this, in our textbook it does have a very nice section. It is a little on the lengthy side though. We are in Chapter 3 and we're looking at pages 65 to 73. And I'm going to use a lot of the graphics from Chapter 3 in today's session. Alright, so here's the first one that I really want to focus on. This obviously is our planet Earth, and here is the Sun. And the Earth, as we look at it, is not straight up and down. And if you've ever seen a globe, most of the time globes do a pretty good job of showing this tilt. And we say that the axis that the Earth revolves on is tilted. And so what that means is the angle that the sunlight comes in here and hits the Earth comes in at different angles. And these angles right in here, the sunlight hits the Earth at a more direct impact. The angle is almost, if you talk about math class, almost a perpendicular type of angle that comes in. If this little arrow that I put on here is the sun, it's hitting it straight on. But up here, at this point and at this point, we have a little bit of a tilt going on. And we have a tilt here if these lines that I'm drawing represent the Earth. And it's not a head-on angle. And often what happens is this light then is reflected a little bit. So it's at a low angle that the light's coming in. So it's a little bit different as to what's happening. And so because of that, when we try to put some measurements to this that goes on, we have put some measurements around the Earth that we call measurements of latitude. And we start here at 0, that's the equator. And then the next measurement that I want you to know is about 30 degrees north and 30 degrees south. And that's where these dotted lines are. We actually have names for these, the Tropic of Cancer and the Tropic of Capricorn. You wouldn't need to know either one of these. But what I want you to know is from the equator going to that 30 degrees north and 30 degrees south, that's where you have the most direct light. And so if you have more sunlight that's coming in, that's going to give you obviously higher temperatures. You have an increased amount of energy coming in. This is also going to impact the weather in this area. And there are some weather patterns I'll show you here in a second that may cause an increase in rain or a decrease in rain. Now the next section here, I'll change colors for you. Maybe we'll go to yellow. This section right here, about 60 to 30, and I put a little yellow line in here. This is more of it's not too hot, it's not cold, it's just right. So we call this a temperate. Temperate, a temperate climate. And if you look, Ohio would be about right here where I'm putting the circle. So we definitely fit into that category. So usually it's very seasonal. You've got summers, you've got winters, but nothing to the extremes. Now there's one more left, and maybe I'll put this in white up here. These parts up here are called our polar regions, and it happens in the north and south. And there's so few energy coming into these areas that you have very, very cool locations. And it's cool there all the time because this never changes. Alright, so that's just kind of a quick review of temperature for you. Let's move on and take a look at how we could represent this. Oh, I've got one more little thing here. If you're interested more in how ocean currents and winds and weather play a role into this, your textbook on page 67 has really nice resources. Also, just remember, whenever you see this concepts in motion box or this little film box up here, there's some online content that you could check out using that online edition. Alright, so we're going to look at this diagram right here, and it tells us two important pieces of information. One, it tells us about temperature. And I kind of am torn in using this graph because I don't like that it starts here at 30 and then goes to -10. To me, that just doesn't make sense in our number systems. However, this is still a very good way of organizing things. The other thing that it will do is organize based on precipitation. So those are our two variables that we're looking at. And if we look at the extremes, I'll fill those in for you, where it's really cold, really low in precipitation, we call this the tundra. Okay, now how did I know this? Well, one, I am your teacher, so I kind of know what's ahead. But if you're looking in your textbook, they have these nice little sections for each one, and what I want you to look at is this little box right here, average precipitation and temperature range. So it gives you some numerical values that you can use to fill in all of these. So if you have a second tonight, try to fill in all of these locations, and we'll check those in class. There also, I will tell you, there's probably more than one way to fill these in. This is a diagram from your textbook. You're going to find in class, I'm going to group some of these together to make it a little bit easier for you. Okay, so we kind of talked about this idea of latitude. I just introduced it to you a little bit. But now I want to focus on a second part to this, and this is something called altitude. Now, latitude here is what we just talked about. You know, this would be somewhere at 0 degrees, so at our equator. And this polar one would maybe be like 75. This could be either north or south that we're talking about, 75 degrees. Remember, that's how you measure latitude. Altitude, however, talks about how high above sea level the land that you're studying is. How high above sea level is the land. And so let me minimize this over here. We're looking at starting right here. This would be your sea level. And we are going to increase that. A lot of times what you're going to be looking at is some sort of mountain situation. And what happens is as you go higher and higher up a mountain, there's some things that changes. And those two things are, anybody guess, anybody guess? If you said temperature, you are correct. And precipitation. So that it's possible to be at 0 degrees where we think it is really hot and a lot of rain, like a rainforest situation. But because you are so high above sea level, because you exist up here at a very high altitude, you could have a tundra exist. And we'll talk a little bit more about that in class. I'll give you some examples of those. I really like this picture that your textbook uses, and I want to explain that to you in looking at this picture that we talked about earlier, because here's our 0 degrees equator. Alright, and if you increase your latitude, okay, so increasing latitude would be going like this, because you start to 0, 30, 60, same way this way, 0, 30, 60, you go to a tundra ecosystem. So you can go from somewhere that's very tropical to somewhere very, very cold. Altitude works the same way. This time, if we increase our altitude, if we go higher above sea level, you see you have these different bands that form as far as your ecosystems go to where you can ultimately end up with ice and snow. So that's just my short introduction to your biomes. We're going to learn a lot more about the specifics of each of these, but I wanted you to have this background information.